Hey, hi everyone. Hope you're doing well and that you're enjoying all the learning that's been going on in this course. I know we cover a lot of things here, and that's because there's always lots of connections when you talk about environmental issues. So today we're going to talk about transportation. So here's our first slide. You'll see that I took some of these pictures when I was at the Oregon Trail Memorial, just trying to show you that how fast and how far things have gone. And no, I did not take the picture of the transporter room that you see up here, but that would have been cool if I had. So let's get into some of this. So we're going to go over some stuff about society, transportation, a little bit of history. We're going to talk about energy and the nexus of transportation and energy in the environment. So all these things being connected. We'll talk about some terms, and then we'll go over efficiency, because that's really a key. And then methods of transportation, some things, information about logistics, and a little bit of stuff about the future, like where are we going. Okay, so let's start with this, that it's important to recognize some of the things that we may take for granted. So, for example, that transportation has shaped society. And that transportation systems are vital to people, countries, the economy. It improves the quality of life. It already has, because of the things that we get every day. You go to the grocery store and you pick up things. These things were all delivered in one way or another, sometimes from a nearby farm and other times from around the world. It's kind of interesting that a lot of people don't even know what fruits or vegetables are in season, because fruits and vegetables are coming in from all around the world. So we lose sense about local availability of foods. So things get moved around, and with less and less cost. That's what makes them available to us, is because the cost of transportation drops, and then that makes it makes the markets available to farmers to send stuff to us. And then, of course, transportation is now allowed for a lot of movement. People can go from one place to another. Lots of immigration and emigration. Lots of jobs that are related to transportation, and it has also changed where we live and has given rise to cities because people can move around. And the key thing about all this is that it's transportation that fuels globalization. There's actually 4 components to that, and we'll get into that a little bit later. So when we get towards the end of this particular topic, we'll be talking a little bit about how will transportation shape the future, because we don't really know, but we have some pretty good ideas. Will there be more movement of people and stuff if the cost of energy drops, which is likely? Will we have a reduction in pollution, or will there be more pollution that's related to transportation? What about economics and cultural impacts? We know that, for example, that China joined the WTO just a few years ago, at the beginning of the millennia, which had immense changes to China and the availability of goods worldwide, and moving literally tens of millions, probably something more like 300 million people out of poverty. And so with the changes in transportation, will there be even more trade? Will there be less poverty? Or will there be more exploitation of people that are in lesser developed countries? And all that relates to, will there be more social problems, or will there be fewer social problems? And will there be fewer environmental impacts if we were to change our energy sources that we use to power transportation? And I have in here, this is a picture of the Empire State in New York, and over here there's this book, Guns, Germs, and Steel. And one of the things that that author Jared Diamond was pointing out was about how access to peoples on rivers and canals, basically rivers, changed entire cultures. which is exactly true. So you might want to pick that up someday and take a look at it. It was a well-known book, and I believe it won the Pulitzer Prize. So the flows of globalization, the main thing is that it is shaped by what we call trade liberalization. In this hyper-political time, we think a liberal is something, we compare it with conservative, but what we're talking about here is that trade liberalization removes restrictions on barriers on the exchange of goods between nations. So you've probably heard about tariffs, and then there's things like duties and surcharges. Well, the point of the World Trade Organization, which was originally GATT, was to remove these things, remove these barriers so that you have more flow of goods because you can reduce the cost of goods and you connect countries economically. And when countries are connected economically, people get more of what they want and what they need, and it actually promotes peace. And whereas we had World War I that ended in the 1920s, something like, or before 1920, about 1918. And then we had World War II that took off again in 1939. But we seem to be not having these global conflicts since the end of World War II in 1945. So it's important to recognize the power of trade liberalization. So the other thing that's massively influenced the flow of globalization has been the sharply declining cost of communications and transportation. So many of you grew up with cell phones, and some others of you still remember the dial-up sounds of your internet. And then others like me, we had no internet, and we had no computers. So we've seen all those things change, which is and the cost of devices to provide for communications have dropped dramatically. I remember buying a computer at $6,000 that I can buy today. That for $150, that's multiple times more powerful and quicker. So the point is simply that as communication costs drop, that also helps fuel globalization, and as costs of transportation drop, that also fuels the flow of goods. So there's been this explosion of e-based connectivity since 1995. And so many of you will probably be ordering, and you probably already do, order things from Amazon or order things off of your phone from food companies to deliver things to you. So, and many of those food products actually have ingredients that come from other countries. So let's talk a little bit about global outsourcing. What it really is then is that it's equal to the networking of service providers and expanding trade of goods and services, which drives global growth dynamics and also ends up creating ecological footprints. So perhaps hopefully you remember the assignment we did that was related to that, where we saw that what we consume in one country creates an environmental or ecological footprint onto another. So trade, as you know from an earlier lecture, has been growing exponentially. From 1970 to 2010, it's grown by a factor of 48. The GDP has grown by over 22 times, whereas the population has grown not quite double. Since 1970. In my lifetime, the global population has tripled. So the ongoing growth of international trade is facilitated then by the growth of containerization. So that means ships, and we'll get into that a little bit more later, and the growth of trade from the Pacific Asian countries. So that would mean, we typically think of China, but then there are others, right? There's India, of course, and then we have goods that come in from the Philippines and from the Koreas. or I'm sorry, South Korea, not the Koreas. Nothing comes in from North Korea. And then there's the growing role of multinationals. So that means multinational corporations, companies that are basically have economies that are bigger than many countries. And it's because they're in multiple countries. Okay, so more about the facilitation of trade. By 2007, international trade surpassed 50% of the global gross domestic product, or the GDP, right? So massive, massive increase. So for those of you that think that we can roll the clock back and not have globalization, or the anti-globalist, which Donald Trump was often talking about, well, that's clearly the voice of nonsense, because of this massive number here. Globalization is here, it's here to stay, and the only thing we can do, frankly, is guide it. So these four factors, which I had mentioned earlier, this is what's really been driving globalization, and it all relates to transportation. So the one is tariffs, that they're low or zero because of the WTO. When tariffs are enacted, such as when Trump did, there'll be a violation of WTO, there'll be hearings, and the U.S. will lose, and then the U.S. will have to pay, which has already happened in some of these cases, but I'm not going to get into that now. And then the other is transactions. So there's more transactions because of globalization. And time cost. Everything moves faster because of electronic transportation or electronic communications. And then lastly is these elements of transportation. So the key thing about transportation is that it has methods of transportation have consistently been moving towards efficiency. And when they move towards efficiency, what that means is that they reduce the cost of transportation, which means that you increase the profitability. But also when you increase efficiency and lowering cost, then that means you can reach more markets. So the key innovation has been container ships and containers. It's a completely unsexy thing, but we're just talking about a metal box. And there's this book, great book. I loved it. Most people thought I was kind of silly reading a book about a metal box, but you see how this thing changed the world. And then the other thing about these is that after there's a delivery, like when goods come in from Asia, then these containers are then filled up with recyclables and sent back. So that's called backhauling or reverse distribution. Very efficient, because then those products or those recyclables are made into products and sent back to us. And the bad thing about that, of course, is that we're sending Asian countries our recyclables, and then so they get the benefits of these resources, and then we buy them back from them in the form of products, so they make money from us. And then because our country is continuously running a debt, it's China that ends up loaning us money, which was originally our money in the first place. It's just that our political people aren't smart enough to make some changes so that we can create more markets for recyclables right here. So I won't get into more of that at this time. You'll have to take my recycling course, I suppose, Environmental Studies 148. So the other thing that's happened with improvements in transportation efficiency is our investments in maritime infrastructure. So that's about ships. So there's more investments that have been made in ports and containerization. That means you have to have cranes and machines that can pluck these containers off of cargo ships and then move them right onto trucks and trains. So here are these cargo containers up here, and you have to have machines that will pluck them off the ships that you see up here. So bottom line is that there's a net decrease in transportation costs, and what that means is more trade. Okay, a little bit of history here. So rivers and canals then opened areas of the world to commerce. Let me fix that. And so we know about Columbus. He was looking for spices, right? And and because that's what they needed, because there were no such things as refrigerators, so it was spices that were used to preserve food, meat in particular. Canals opened the world even further, rail in the late 1800s, and highways in the mid 1900s. If you look at things like oceans and rail, you can learn about some of the old, the rich people in the world, the Vanderbilts, that got rich from cargo ships, and then there were all the rail barons that the Big Four, right? The Crocker and those guys. So we go from there into the 1830s. We started with things like horse-drawn public transportation. So you have just in New York 100 to 200,000 horses, and you have to deal with all the manure every day. You can only imagine what it was like walking around in those days. And then that was replaced with elevated trains. The bad sign about that is that they burned coal in those times, and there's lots of fumes, lots of smoke, dirty, noisy, and then eventually that gets replaced by electric trains, or with electric trains. And then ultimately there's the subway in New York City. So this just shows you this this continuous movement towards improvement, efficiency, reducing costs, and actually reducing pollutants as well. So here's something that's pretty impressive. In the 70-year time frame, we went from riding horses to reaching space. Just phenomenal, if you think about it, from 1890s riding horses to the 1960s reaching space. And then you look at this other little time frame here, less than 30 years we went from propellers to jets. So it was the Wright brothers, of course, that invented the first plane that would fly, with a motorized plane, and then they were also responsible for the first cargo flight. They actually were moving silk from Dayton to Columbus. I'm sure it's because it was lightweight. But then you have, just 20 years after that first cargo flight, the jet engine is developed. And here's a jet engine. Basically what that does is just it compresses air and it forces it through and makes the plane fly. There's a lot more to it, but it was jets that allowed people and things to move faster and to carry more things. And then here we go from there, just another 30 years later. It's not just jets. We have rockets, and then we went to the moon just a few years after that. Now we're planning to go back finally. But it was JFK, John F. Kennedy, that made the proclamation about in the early 60s about going to the moon and coming back, and then that was accomplished before the decade was over in 1969. So there were some mistakes along the way. We had mass transit systems in the United States. There were a lot of trolleys, and then they were destroyed. Many of them were destroyed. Some of them were not, like in San Francisco, but most were gone, including one in San Jose. So we had some of the best streetcar systems, but beginning in 1931, there was a company known as National City Lines, and what they were doing was going around and buying up trolley systems and then destroying them. They would destroy the trolley cars, here you'll see them, and they were also digging up the rail lines, and because basically the owners of National City Lines wanted to sell to government their products. So General Motors, Chevron, and Firestone were all owners of National City Lines. General Motors wanted to sell buses, Chevron wanted to sell fuel for the buses, and Firestone wanted to sell tires for the buses. So this is clearly collusion, and the courts thought so, and the NCL was convicted. I believe the fine was an inconsequential amount. It was like $1 or something like that, because nothing changed. There were no real damages that were properly assessed to the collusion, the illegal collusion that happened. So the net impacts of this is that we ended up with more roads, more cars, more fuel being consumed, the need for oil imports because we exceeded what the United States was producing at that time, air pollution, particulate air pollution, sulfur dioxide, nitrogen oxide, acid rain, cancers, asthma, greenhouse gases, urban sprawl, taxpayer cost to support collecting or paying for all this stuff. And then ultimately, here it is 50 plus years later, light rail returns to San Jose at the cost of millions of dollars. So just a little historical component here. These are some photos of some past trolley cars. There's a trolley barn at the Historical Museum in San Jose, which my dad actually had worked at. He worked on restoring these trolley cars from the 30s, and then it's kind of interesting over here on the corner of Alum Rock and Penitencia Creek Road, which is, if you take Santa Clara Street and just drive out, it turns into Alum Rock, and you can go up and you'll see this old abutment here. The trolley car in San Jose used to run up to Alum Rock Park so that people could get out of the cities and go up and enjoy nature. So that's still here. Just thought I'd let you know. Okay, so the question then is, so what are we going to do? What will the future be? Are we going to move towards more light rail and transportation systems like that? But even if we did, that's just dealing with moving people. Well, we need to talk about freight. And then the other is like, well, what kind of fuel do we want to use in vehicles? So I'd say like the days of the Corvettes and the cars that get very low mileage are over, but you can still have a pretty hot car, fast car, when they're electric. I've seen those, and they're pretty awesome. Okay, so, or will we end up somewhere in the middle? So, when you think about a city is kind of like a living body. It has things that come in and things that come out, right? So the inputs, energy, food, water, raw materials, manufactured goods, money and information, and what's key for the delivery of materials and goods is transportation. And what transportation needs is energy. So this is what we're going to be focusing on, or that's what we will be focusing on as we move through this lecture. And the outputs of a city, of course, solid waste, which include recyclables and all these other problems, waste heat, pollution, air and water pollution, greenhouse gases. Cities also send out their own manufactured goods. Of course, there's noise and wealth, and then there's ideas that come out of cities. So we have to consider how to make improvements, because we want to reduce the negatives of these outputs here. But we want to be able to do that without jeopardizing the future. In fact, what we want to do is make the future better. Okay, so we needed to talk about energy then. So transportation requires energy. So first we know that the energy sources that were used was muscle, human and animal muscle. Then later it was wind, sails, windmills, things like that. It's a nice windmill you can go look at Golden Gate Park in San Francisco if you need to go out and have a good time. In fact, I hear there's a Ferris wheel that's out there temporarily. You might go check that out. And then after we moved from wind, we got into steam, right? So steam was a result of James Watt inventing the coal-fired steam engine, and that led to the Industrial Revolution, which led to, of course, all the greenhouse gases and pollution that we have today, but also tremendous evolution of humans. And the steamboat then was invented by Robert Fulton because he took James Watt's idea and then used that steamboat to be moving goods along the Erie Canal, and that's what helped make New York as successful as it was, because it was running goods to New York City. And they were making a profit, so this was an indication to continue doing, because profit generally is an indication of something that's working well, and then we want to do more of it. So we started moving into carbon fuels. So that means the non-renewable resources like coal, oil, natural gas, right? Natural gas being methane. So cheap oil then changes the world, mostly right after World War I, when the English Navy switched to oil because it used less space inside of their ships, which worked out well for them when the war broke out, because they were able to move their ships much faster. So I won't get into all that stuff. But so gasoline and diesel fuels are also, of course, no surprise here, the greatest source of air pollution and greenhouse gases, primarily carbon dioxide, but there are others. But from burning gasoline and diesel, we convert the oil that was made into gasoline into air pollutants and greenhouse gases. So transportation is responsible for about a quarter of the global energy consumption, and because petroleum, when it's burned, is and internal combustion engines are inefficient, we only use maybe 25% at the most of that energy. So 9 of 12 gallons of gasoline is going to be wasted as heat. So this inefficiency actually points out the opportunity for significant efficiency improvements. So the internal combustion engine, I know some people don't understand how these things work, even though you drive a car, but basically what happens is this is the inside of your engine, and here's a piston here. And so internal combustion simply means some gasoline gets squirted in here, and then it combusts, and when it does, the piston moves down, turns this crankshaft, which is eventually connected to the wheels, and off you go. So it's internal and it's combusting, okay? So the cool thing about it is that this engine was smaller, and because it was smaller, it could go into more things. You could also make it bigger and put it into things like ships, and so these are the things that happened. And the great thing about internal combustion engines is that they had they're smaller, larger range, greater flexibility, and they were better than the electric cars of the day or even steam-powered cars of the day. And also, this is the same reasoning that the English Navy switched to oil around the time of World War I. And Henry Ford invents, of course, the Model T and the Model A, and then that creates this cars culture. So from because people are driving cars, there's a greater demand for paved roads. There was a need to find a way to pay for these roads, which is taxes. So we have the creation of the gasoline tax. Ownership of cars grew greatly after World War II. So that means in the 1950s, essentially. And Eisenhower is president, and then he proposes and gets passed the National Highway System, which is basically a program to connect every state capital with by road, so you can connect all of them. And this was immensely successful. I've been on many of those roads because of this highway system. And so this again was the federal gas tax that allowed this to happen. And then you have people on road trips because you can. So the key thing with all this is that because of the lower cost of energy, because of the internal combustion engine, it allowed for more movement of people and things, right? And the key part about things is that the internal combustion engine is used in trucks to enable the movement of freight, and in ships to now allow for the movement of freight. So the downsides that society gets built around cars, air pollution, greenhouse gases. We go to war related to oil. Many people point to the whole Iran and Iraq wars that were all related to oil. We have acid rain, acid deposition. It's known as pollution, accidents and injuries from people in automobiles, which I'm sure some of you are familiar with. I know I am. And then we also have people that have lost land, property, because of roads. Much of New York City was taken out. Parts of San Francisco were in order to build highways. And so there's also the hidden cost. You may not realize that there are subsidies that go from the government, meaning your taxes, and there's tax breaks for oil companies and road builders. $20 billion worth in 2017, that is. And this is not likely to change, although we're hoping so with a new administration in the White House. So, and then there's other things that you don't pay for directly. There's the military protection of oil sources and the cost of regulation and enforcement and of regulation and road building and maintenance and foreign aid. All these things are related to maintaining the flow of oil so we can continue using this oil as a mechanism for to fuel the economy. And then there's the cost that industry has because of pollution control and cleanup, which they typically fight, but we have regulations now that are trying to protect the public health. And then you have societal health, or societal costs. People have problems, health problems that are related to air pollution in cars and injuries and cancers from air pollutants, etc. Cost of war, having to go to war, and some of you have family and have paid dearly here as well. So the remedies are diversifying fuel sources, right? It's not just continuing to pump more oil, but to find something that's cleaner. And then we have to find markets that we have to develop markets for the vehicles that would use those fuels. So, for example, electric cars or hydrogen-powered vehicles. So we have to develop efficiencies to move goods, which we've been doing with things like the container ship. And then we need to have regulations that value energy efficiency and pollution reduction and internalizing externalities to business and that value health, because when we do that, we start moving towards reducing the pollution, increasing the cost effectiveness of transportation, and saving taxpayers money. So with all that regulation, it means there's a lot of agencies out there. So this is just the federal agencies, right? It was created in 1966, and in 2021 the budget was over $74 billion and 55,000. These are just federal employees. And who knows, maybe that'll be a career for you, working for one of these agencies. And let's not forget that there's also state, county, city, and local agency transportation planners and organizations like the Metro Systems and the Santa Clara Valley Transit Authority, and on like that. ACE Trained and the Peninsula Trains and the rest. They all have the local administrators. Okay, so let's talk about a few terms, and I'll see if I can pick it up a little bit here. So there's passenger miles per gallon. This is how you can evaluate the energy efficiency of a mode of transportation. And then the reality is that all energy sources are measured by the British Thermal Unit, or the BTU. That's just a unit to describe the heat value or the energy content of a fuel. And then there's greenhouse gases, GHGs. And then here's one that you're probably not familiar with and haven't heard of. It's TEUs. So this is a 20-foot equivalent unit. It's about measuring cargo capacity on this this intermodal container. And so what that really means, intermodal, just means that you have this container that can be put onto a cargo ship, like over here the M.M. Maersk, and then it can go from the cargo ship to a train to a truck. Intermodal, right? Can be used in different things, but it's basically used to determine this term is used to determine capacity of these ships or trains or trucks. So let's look at the problem so we can develop a solution. So we see here this is energy consumption by source in quadrillion BTUs, or quads we call them. So you'll see that the primary energy source here is petroleum. So that's what we use to get, that's oil to make gasoline. You can see here's renewables going up. That's good to know. Coal's going down. That's good. Natural gas has been going up. Some people see that as bad. I see it as good because natural gas has much fewer pollutants than petroleum, and it's really a transition fuel. So as we use natural gas, we start moving away from petroleum and more into renewables as renewables get better. I'm not a fan of nuclear. There are some people who are, but I don't see it being in any way whatsoever being having any positives. But I'm not going to discuss that right now. So if petroleum is up here, then you look at the end-use sector. So what's using these fuels? Well, mostly it's transportation, right? So if we can improve the efficiency of transportation, we can reduce the use of this petroleum, which means that we'll have less air pollution, less money that flows out of the country to buy oil, and all those other negatives that I was pointing out before, all of them drop. So when we're talking about BTUs, you can see here a gallon of gasoline is about 116,000 BTUs. Okay. So what about greenhouse gases? So when you look at these figures here, you can see that transportation, right here, this circle, is about 28% of the United States greenhouse gas emissions, right? And then you take this and you project it out here, and you see that there are all these different mechanisms of transportation. There's rail, marine, which means ships, cargo ships, aircraft, jets, and the like. And then you have light and heavy-duty vehicles. So those vehicles alone, you add up those numbers, that's nearly 80% of greenhouse gas emissions in the United States. So what makes sense then is to always focus on the biggest part of the problem. And so where's the biggest part of the problem? Vehicles, right here. These are the things that need to change. Yet one of the problems that we're having is that we're using more of these light-duty vehicles because of the growth of e-commerce, right? You have all these Amazon trucks and FedEx and UPS driving around delivering goods. And so that makes this more difficult to reduce this. Over here, by the way, this is an overview of greenhouse gas emissions. Most of them is carbon dioxide. And then you'll see over here methane and NOx, nitrous oxide, and then fluorinated gases. That means chlorofluorocarbons, which have been getting phased out for a number of years. So there's very few of those anymore. But they tend to hang around in the atmosphere for, we think, maybe as long as 100 years. Methane, on the other hand, even though it's so small, methane holds about 22 times more heat than CO2. So we want to always avoid methane. In fact, we have programs now to collect methane and burn it, which then creates CO2, but you go from something that holds 22 times energy to something that only holds 1 times energy, or double its weight. Okay, so energy CO2 emissions by sector So if you compare transportation to some of these others, again, you'll see transportation has the highest, right? This is, and then over here, again, it's transportation. So I'm just trying to point out that transportation is the key, or improving efficiency in transportation is the key to reduce these negative emissions. So if we're going to do that, efficiency in transportation involves more than just changing the fuels. You have to have the infrastructure. So the availability of infrastructure can either promote trade or inhibit trade. And so that means you have to have these ports, airports, and equipment and cranes and vehicles to make all this happen. And then you have to have the services that will support that. That means about people and logistics and finance and markets and marketing. All of these things relate to jobs that you might be interested in as you work through your college career. Hopefully you're thinking about jobs right now. You should spend some time looking out there on the internet about potential jobs to decide if you're in the right major and you're taking the right courses. And then there's other things over here, transactional things, again, political, financial, cultural settings, legal things, exchange rates, all this relates to, again, careers. And then airports. One thing that's interesting about infrastructure at airports is that they're used quite a bit, but there's really a relatively small amount of freight compared to maritime freight. Why? Because it's so much more expensive. It's only about 15% of the total value of goods because it's so much more expensive to fly things. So let's look at this here about these factors. This first chart up here is just showing you maritime freight rates. This is the cost of delivering goods on ships in Asia and Europe. Fairly steady. But these other factors that relate to infrastructure and transportation costs will be labor, warehousing, and the environment. All of these factors here, you can take your time and read those. But the goal in all of it is to consider these driving forces: quality, speed, efficiency, improving these while dropping the cost. Okay, so and the point about that is that we don't want to overlook or underestimate the motivation. So the motivations for industry will always be profit. And another motivation from industry will be to avoid legislation and regulation, or legs and regs as I call them. And the way they avoid legislation and regulation is to improve their performance. Meanwhile, what government does is look at the problems that are happening and then trying to apply solutions that end up getting impressed upon business. This is what business doesn't like. So if business doesn't like these things, then what they have to do is change their behavior, because the problems are what they are. Global climate change is here. We have to make changes. It's government that will enforce these regulations on industry, because industry concurrently, they don't have to pay for those costs, so they don't. It's not part of the cost of business unless government makes that a cost of business, which is what we did in California with AB 32. It's about reducing greenhouse gases and putting a cost on business. So increasing energy sustainability. The problem is that nearly all vehicles are using oil. So the solution again is we need to move towards efficiency and conservation. That means using fuel better and finding alternative fuels and then using those. So for example, there's things like this. What this diagram here is showing you is a vehicle that's fueled by hydrogen. So plug-in cars might work, but then that puts a demand on the electric system. Same thing with freight trucks and the rest of those. So we need to be moving away from electricity or having electricity being produced by renewable sources. So efficiency will reduce the problem and can maintain profit. It will reduce climate change. So the solutions, again, using low or no carbon fuels, and then looking at alternatives to what we're currently doing now, and maximizing freight efficiency, which just simply means carrying more stuff and getting more passenger miles when they're delivering goods. So we want to get a higher, basically, MPG that ends up making less carbon dioxide. So what's the most efficient? Well, we're not going to spend much time on personal stuff, but there's motorcycles, automobiles, light trucks, buses, and that I'll show you some figures. We'll spend more time here on freight. So here are some energy efficiency breakdowns for you. We're looking at, again, comparing passenger miles per gallon, the PG. So no surprise here. Motorcycles do the best. And then you'll see light trucks that they've been getting better over the years, and automobiles. But then you come over here and you see what's even better are trains, and to some degree buses. So let's get into some things about freight. But first I want to understand that what some issues relate to the mobility of passengers and freight. So if you look at this chart, you see this blue line here. And basically what it's saying is that there's a lot of people that take short trips. They don't tend to go long distances, but what does go long distances is freight. So this points out the importance of trying to reduce these impacts of freight when it travels long distances. So we're going to look at cost and other factors that affect freight efficiency. So what method really does deliver freight at the lowest cost and the lowest amount of environmental impact? So they consider things like cost, the damages that happen to products, the time it takes to move goods, the use of intermodal solutions, because you might be able to go from a cargo ship, put it onto a train to get it somewhere in the Midwest quickly, and then move it onto a truck, putting a container on a truck that can then bring it to a distribution center, which can then go on smaller vehicles to get to the stores and or people. And then predictability is critical, and the downstream efficiencies, which I was just talking about how quickly you can get it from trucks and trains and from cargo containers to where people want to buy it. There's also this thought here about downstream efficiency, that if people just consume less, then less stuff gets delivered. Well, is that going to happen? I just don't see that happening, and it's never going to be effective to encourage people to just use less, because you still have a container that has to get delivered from a truck or off of a cargo ship to a truck to a neighborhood, and if there's just 2 or 3 fewer goods in there, is that going to stop the delivery of an entire container? No. So much for that. Okay, so here's freight trains. Very high efficiency rate. They can be quite large. I've seen some of these that have gone on for miles and miles. The limitations is some of the train tracks need to have stronger beds so they can carry more weight. Some bridges are too low, so the trains can't carry double stacks of containers. There are trucks, the 18-wheelers. These are generally good for shorter distances, but they do drive across country, of course, because that's what some companies will prefer, because some items can get held up on train tracks that wouldn't get held up if it's in a freight truck. And then there's jets. So the thing about jets is that these are the least efficient methods and the most costly. So it's important to recognize that's why we don't fly goods essentially from one country to another. We do with some, right? But those would be higher value goods. Most things are going to come across in cargo ships.
And so here are our cargo ships, which are essentially the most efficient. The one thing that they're not good with, of course, would be perishables. That means fruits and vegetables. Those kind of things typically will go on planes. So recognizing the need for efficiency, cargo ships have been getting larger and larger and larger. That's what this diagram shows you. And here's one here, the Fabiola. It is as long as the Empire State Building is high. This is a massive ship, and it's coming to the port of Long Beach, down by LA. And here's another one that's even bigger, the Benjamin Franklin. It can carry 18,000 TEUs. Massive thing. So again, it is longer than the Empire State Building is high. So we put all this together. We look at energy efficiency by transportation mode, and we see that here's most efficient to the least efficient, and then this is speed. So we can see that you can move things by plane, and it'll get there faster, but it's going to be the least energy efficient. It's going to use the most amount of energy. And of course, if it's faster, it's going to be more costly. So that's where you see trains and container ships here, trucks somewhere in the middle. Here's another way of looking at this. The most efficient way of moving something here would be, here's the VLCC. This is a very large container ship. And what these here would be carrying is oil, very large crude carrier. That's what I was trying to say. And they carry oil. And then you have in the this Panamax container ship being much more the next level of efficiency. And then you'll see cars, and then you can compare that with trucks. So again, it's planes that will have the least be the least efficient. And we're looking at emissions. Where are most of the emissions happening? On the roads. No surprise there. And rail is much less, and of course the least is ocean cargo ships. And how much energy is being used? This is the comparison of distances transported for 1 ton of freight with the same energy input. You'll get the most travel from maritime, and then railroads, and then roads. So again, the most efficient way to move goods is maritime. All right. So all this then relates to, again, regulations. So we talked about that a little bit, but let me just point out that the California Air Resources Board created new regulations that basically was created to reduce the amount of air pollution at and near ports. So they require container ships that will come into port to plug into auxiliary power units so that they don't have to be burning crude materials. Like they use some of the worst qualities of oil to burn, which creates massive amounts of air pollution. So this doesn't happen now at docks or at ports. And the other thing that's being required is trucks to be zero emission. So we'll have all freight trucks in California that will be sold by 2045 have to be zero emission, which essentially means electric or hydrogen, if hydrogen is ever made available. Trucks are the single largest source of air pollution from vehicles, and responsible for much of the smog causing pollution, and 80% of the carcinogenic diesel soot. So even though there's very few of them comparatively, they create the most amount of pollution. So this is addressed because of regulation. So And the other thing that's been happening is energy efficiency with trucks and trains, so that they, again, become more cost competitive because they can carry more goods at lower cost. And so in some states you'll see trucks that have 3 trailers and not 2. I've seen this. And in some places trains can carry twice as many containers because they stack them up like what you see here. And then others, if you plan the logistics right, you can move things from trains. You can move cargo containers from trains onto trucks. So let's talk a little bit about the Port of Oakland, because it's near here, near San Jose State, and it's very important. It loads and discharges more than 99% of all the containerized goods that move through Northern California. It's the 7th busiest container port in the United States, and they're actually working on an expansion of it, so it'll be able to process even more things. And this is one of the reasons why they are arguing with the city of Oakland about having the Oakland A's move in their area. And trade from Oakland is basically pretty balanced. Exports and imports about match. And where does most of the trade from Oakland, where is it with? Mostly China, followed by Taiwan and Vietnam, Japan, South Korea, Thailand, India, and Malaysia. And outside of Asia, then it would be Australia, and then Italy, and then Chile. So China's the largest export market, followed by Japan and South Korea and Taiwan. And the UK and Holland, and of course Australia, all fit in there to round out the top 10. So growth in exports has been hampered in recent years because of China's rules about recycled materials. The U.S. has been shipping many recyclables to China, and they tend to be very dirty loads because we're not separating things enough here in the United States. And so China's been creating new rules about how clean the materials have to be, and as a result of that, there's been less material being exported. More on that in my recycling course, Environmental Studies 148. So there's also this uncertainty around tariffs, which were a problem that was created by President Trump. And so it's thought that some of the tariffs, or some of the pushback from China on the tariffs, has been restricting the flow of recycled goods. Okay, so Port of Oakland, then, top exports have been, in case you're interested in this kind of thing, almonds, walnuts, pistachios, hazelnuts. So this is where much of our water is also being used for, and beef, which we use most of our water for things like alfalfa to feed beef. And then there's other types of meat, like in particular pork, and then here's the alfalfa that I was mentioning. We also export alfalfa, strange enough, but it's true. But alfalfa uses about 80% of the water, and we use enough water on alfalfa in California as the amount of water used by LA, San Diego, San Francisco, San Jose combined, in times by about a factor of 2. So by tonnage, exports include it's scrap, it's recyclables. You'll see here's paper, and here's scrap iron and steel. And imports, stuff that we're bringing into the United States through Oakland, include computers, chemical products. In fact, the computer I'm using probably came through that port. And we're also importing wine and furniture parts, and containers for packaging. Okay, and this is interesting. About a third of recyclables recovered in California are exported from ports like Oakland, and waste paper accounted for about over half of all the exports to China in 2017. So if you're wondering where all your forests are, I can tell you that they're in containers being shipped to China. Oh, and by the way, you subsidize the cutting of forests to do that. So the good thing is that we're talking about when we send those recyclables that it's what we call reverse distribution or backhauling, and it simply means this that a cargo ship comes into Oakland and is selling goods, and then when it returns, it doesn't want to return empty. So instead, they purchase recyclables and fill up the cargo ship. So typically, when a cargo ship comes in, the price of recyclables go up because there's a market. So you can see here that initially you have supplies that go to producers, and then there's an exchange with distributors. Consumers buy the stuff, and then they discard goods that end up being recycled, and then that gets sold back to suppliers, and then here's where the cargo ship goes back to Asia, where they then take those materials and they make them back into things, and then here you have this cycle, right? That's also what this shows here. This is a little bit more in depth, this logistics cycle here. So the idea here is that we start moving away from this open loops to this closed circle or closed loops, right? So when you have closed loop, you're taking recyclables and then turning them into products, and in doing that you have less environmental impact, less habitat disruption, less pollution, fewer greenhouse gases, and less landfill material. This is all good stuff, and it makes transportation more efficient. So the paradox here is that trade enables a lot of countries to mask their energy consumption and pollutant emissions, but of course you know that because we did that paper on from Davernier about ecological footprints. So that's basically what this slide here is showing you. And then this one here about environmental dimensions of transportation, simply that there are all these relationships that happen, and you can take your time and follow this chart around to understand it, but there are impacts on things like land use, and then there are all these infrastructure issues that have to be considered in making transportation work. And then we have all these negative inputs or outputs here on the environment, and then many of those relate to social impacts, and then all of that involves policy making, and that may be another career for you when you're involved in policy. So take some time and look at that chart on your own, and then that relates to this thing here about sustainable development, which essentially is about internalizing externalities. And it's just pointing out that it's policy that will determine legislation, and it's legislation that determines regulation, and then it's the regulators that will determine implementation by industry that creates those problems. So you see here with green logistics, it's simply about that there's a number of things that have to be considered to close open loops. And so can we merge those things? And here's something here about the paradoxes of green logistics. And again, it's just pointing out these are the issues that are related to what has to happen: cost, time, the networks, reliability, warehousing, e-commerce, and then the outcomes and the paradox, and then over here in this blue column at the far right are some solutions. So come back, take a look at this on your own, read these things carefully so you understand them. You'll need to know this stuff when you write the final paper, because it really helps you understand efficiency with transportation. So you know, the vicious circle from an environmental perspective is that bottom line is that it's more consumption of goods, which means more impact. So how can we reduce those impacts? Basically more recycling of materials, and things like having a more efficient packaging, more efficient transportation. And I haven't even got into the stuff about distribution centers, and again I'm going to leave that up to you to read that on your own. So the grand challenge then for us is a variety of things, but from the optimistic point of view, the trend of history has always been to improve. But if you're a realist, you see that we've been approaching environmental limits, and we're approaching them fast. Global climate change it's not a theory, it's here, it's happening. So we need to act to reduce the scope of the problems immediately, not years from now, immediately. In fact, we should have been doing this decades ago. The other challenge is understanding that profit is the language and it's the motivator. So we have to be working within the reality of business. I'm not saying that we don't challenge profit, but that costs need to be internalized. We want to improve liberties of travel, and we want to get benefits of energy without the negatives, and understanding that policy is the hammer, and we need to develop and implement policies that will reduce pollutants. So technology is going to play a huge role in all this, because that's what has the potential to reduce the fuel demands and has the potential to improve efficiency. And as these technologies enter the marketplace, they're going to be picked up because of these different factors, because they drop the cost of doing business, and just making things better. So bottom line here is that it's policy, policy, policy. It's policies that will encourage or require adoption of improved technologies, and industry will either agree to will try to avoid legs and regs by improving their behavior, or it'll be forced upon them. And if you're a dirty industry, you'll probably have significant cost and or be forced out of business because you haven't evolved. That's my thought on it. So the future is what's best for the economy and sustainability. Well, improving efficiency, encouraging clean tech, alternative fuels. So we're probably going to be we are moving from gas-powered vehicles and transportation to hybrids, to all electric, to hydrogen. And that's if hydrogen, many of the problems with hydrogen are met. Zero-emission vehicles could be the single greatest efficiency improvement in not just a lifetime, but multiple lifetimes. You can go back to James Watt and say this would be the greatest single improvement, is to have zero emissions. So the key is going to be how do we produce hydrogen? Because currently we use natural gas to make it, but we have to find something even better. And other things that could be happening would be autonomous vehicles, driverless trucks, freight delivery, driverless cars, because you'll have fewer accidents, more on-time delivery, less traffic, fewer problems that are caused by user error. But would that be accepted by the public? And then will the insurance companies agree to it? Because ultimately they're the ones that will be determining the fate of autonomous vehicles, not the public, but who pays when there's an accident. So electricity is good, in that it doesn't produce as much pollution, doesn't produce any locally. But again, the production of it relies primarily on carbon fuels, although there is, of course, renewables that are also used to produce electricity. And there's going to be a lot of battles over that, over which method will be will be used to produce electricity. Will it be nuclear? I hope not, because even though it's completely clean, there's also no way to avoid nuclear waste, and they're inherently dangerous. All you got to do is pay attention to what happened in Fukushima, Japan. Photovoltaic panels get a lot of press and knowledge, but the reality is you can't recycle them, and batteries need a significant advancement so they can hold more material, more energy. And then there's other things with alternative fuels. So it's important to understand that freight transportation is profit-driven, sustainability is a developing concept, and we're going to need planners and engineers and innovators and policymakers to start moving this stuff along faster and better. And so there's a lot of career opportunities there. So what will the future be, right? Are we going to have just plug-in electric, where we have the Hyperloop, autonomous trucks, high-speed rail, transporter rooms with Star Trek stuff. So some of it's here already, because we have BART that's been coming into, is now coming into the Berryessa station in San Jose and the Milpitas station. It's one of my students looking out over the construction site when this was being built. And downtown San Jose, this is an idea about how BART would work. When BART comes through downtown San Jose, it's going to come right down Santa Clara Street, just a few blocks from our campus, and it'll be right in front of City Hall. And then there's things like this, the Spartan Superway. This is actually a model. It's a professor at San Jose State. This is a group of my students that went out to go see this. There's things like maglev trains. These are trains that work using magnets, essentially, so that there's very little friction. Less friction means less energy. And I've actually saw a person push one of these trains because there was no friction. It was a pretty amazing thing to see. And they exist in many countries. That's what you see here. And then in California, we have a high-speed rail that's being built currently. There's talk about, and here's the map of high-speed rail, where it will go. There's talk about high-speed rail around the country. This might be part of infrastructure legislation that if Congress can ever get moving on that kind of thing, it would greatly reduce the amount of air pollution, the amount of energy that's needed, and increase the efficiency of moving freight. So, we have driverless cars, flying cars, electric bikes, some kind of weird skate thing here. There's the Hyperloop. Basically, the way a Hyperloop works is that it takes all the air out, so there's less friction, and then what's inside can rocket along at a few hundred miles an hour. Will people be flying around through the sky? I hope not. Segways and the drone delivery, probably something we'll see more of, I would guess. You're aware of the scooters and monorails, driverless trucks, autonomous trucks, and then cars and vehicles that will communicate with each other when they're on the highway. So there are a few sources in there that are listed here from this presentation. You can look up. But there you go. We're at the end of the line. Don't take this train, because that'll be bad news at the end there. All right, have a good one. Hope you enjoyed it.